Puri Day. Today again I'll continue with the carbon and its compounds chapter according to ICSE syllabus class 8. Today I'm going to discuss, start with the amorphous form of carbon, which is lamp black or soot. Okay. So it is this lamp black or soot, it is a light black powder which has a very soft, when we touch it we feel it is very soft and it's velvety. Okay. You must have seen in olden days our grandmothers used to use this lamp soot for making kajal. Okay. This is the thing. Okay, it contains 98 to 99% of carbon. It is prepared by heating carbon rich substances like turpentine oil, kerosene oil in limited supply of air. Okay, the oil burns with a sooty flame that contains large amount of free carbon. The black smoke which comes out from the when the this carbon is burning, then that smoke is collected, okay, in the form of black powder. It comes as in the form of black powder over damp blankets inside the chambers. The black smoke is collected in the form of black powder over damp blankets inside the chambers. Okay, and that is known as lamp black or soot. Okay, it is prepared in this way. Okay, what do? We burn the carbon rich substance, that is any oil. It may be mustard oil also, if we burn, or turpentine oil or kerosene oil. And if we burn this oil, when oil is burning, it produces a sooty flame that contains a large number of free carbon. And that sooty flame, that black smoke which is coming out, is collected in the form of a black powder over damp blankets inside the chambers, and that is known as that is how this black soot or lamp black or soot is collected. Now, what are the uses? I told you, in the olden days, we have seen, even nowadays also, people they make kajal or eyeliner from these lamp black, okay, due to its black powdery nature. Then it's used in making black shoe polishes, carbon paper, then printing ink, black paint, okay, etc. Then they are used in the manufacture of tires and gunpowder also. Okay, next is gas carbon. Okay, this is also an amorphous form of carbon. Okay, it's a gray solid which is prepared by destructive distillation of coal, or when petroleum products are heated at high temperature in closed container. Okay, either we we burn the coal in a limited supply of air, that is destructive distillation of coal, or if we burn petroleum products, heat petroleum products at high temperature in a closed container, then we can get this gray solid which is known as gas carbon. The carbon particles which are deposited on the walls of the container after the coal or petroleum product is burned, this is known as gas carbon. Okay, and the uses are: it is used for making electrodes of dry cells, it's used in making the lining of electrolytic cells, even it is used in the making of carbon rods for arc lamps. For arc lamps, these carbon rods are made, and which is made up of gas carbon. Okay, now we come to the gaseous form of carbon. Okay, these were the previous one were the solid forms of carbon, and now we come to the gaseous form of carbon. Now, one of the most important constituent of air is carbon dioxide. Okay, and it has been discovered by Van Helmont in 1630 by burning charcoal in air. He burned the charcoal in air in 1630 and discovered this gas. Okay, and in 1775, Joseph Black obtained this carbon dioxide by the action of dilute acids on metal carbonates. So Van Helmont in 1630, he burned charcoal in air and found this gas, discovered this gas. Then in 1775, Joseph Black, he also obtained this gas by reacting dilute acids on metal carbonates, and discovered this gas. Okay, then later Antoine Lavoisier, he studied the gas and named it at acid carbonic. He named the gas as acid carbonic. First, the carbon dioxide was named as acid carbonic. He found that the gas was an oxide of carbon which dissolved in water, producing an acid solution. When it dissolves in water, it produces an acid solution. He found that, and later he named this substance, this gas, as carbon dioxide. Now, occurrence. It both occurs in free state, also in the combined state. Okay, in the free state, it occurs about 0.03% to 0.04% by volume of carbon dioxide. It is present in air. Okay, in the air, carbon dioxide is present in about 0.03 to 0.05% by volume. Also, it is present in the rocks of volcanic regions. Okay, now carbon dioxide is present in dissolved state in natural water, as it is fairly soluble in water. Fairly soluble in water, and that's why it is found in the dissolved state in the natural water. In the combined state, it occurs as metallic carbonates and bicarbonates in the earth's crust and also in the seashells. The chief minerals containing carbon dioxide are dolomite, limestone, etc. Carbon dioxide are MgCO3, CaCO3, this dolomite, and this limestone is CaCO3. Okay, calcium carbonate, and dolomite is a mixture of magnesium and calcium carbonate. Now there's a note that all life forms are based on carbon containing molecules, that is proteins, carbohydrates, fats, nucleic acids, vitamins, or all the forms of carbon containing compounds. Okay, the exoskeleton and endoskeleton of various animals, they are formed of carbonic salts. Okay, next is how to prepare carbon dioxide, how it is prepared. See, there are some processes. So first is let us discuss the burning of carbon and its compounds. When we burn carbon, that is charcoal or coke or any carbon compounds, it produces carbon dioxide. For example, see, when coke is burned or charcoal is burned, that is pure form of carbon. Okay, that is carbon we are burning. So carbon plus oxygen, when it's burning, that we need oxygen. Excuse me. Carbon combines with oxygen to form carbon dioxide, and large amount of heat is liberated. That is, it's an exothermic reaction. Again, when carbon compounds like methane, ethane, these compounds are burned, and that is, it combines with oxygen to form carbon dioxide and water. Okay. Now, if we heat metal carbonates and bicarbonates, they decompose into, on strong heating, they decompose to produce carbon dioxide. For example, copper carbonate, if we heat, it will give us copper oxide and carbon dioxide. Or bicarbonate like sodium hydrogen carbonate or sodium bicarbonate, when we heat it, it's the same thing. Sodium bicarbonate and sodium hydrogen carbonate, they are the same thing. So sodium bicarbonate, if we heat it, it will decompose into sodium carbonate, water, and carbon dioxide will be liberated. Again, by the action of dilute acids on metallic carbonates and bicarbonates. When we add dilute acids on metallic carbonates or bicarbonates, it produces carbon dioxide. So they react with these metallic carbonates and bicarbonates, they react with acids to form dilute acids to form carbon dioxide. For example, see, calcium carbonate reacting with hydrochloric acid, giving as calcium chloride, water, and carbon dioxide. Sodium carbonate reacting with sulfuric acid, obviously dilute sulfuric acid, to give us sodium sulfate, water, and carbon dioxide. Sodium carbonate reacting with dilute hydrochloric acid to form sodium chloride, water, and carbon dioxide. Sodium hydrogen carbonate or sodium bicarbonate reacting with HCl, that is dilute hydrochloric acid, to form sodium chloride, water, and carbon dioxide. Then sodium carbonate, which reacts with acetic acid, okay, or vinegar, you can say. It will react to form sodium acetate, and water and carbon dioxide will be formed. Okay, the acetic acid formula is this one, CH3COOH. Okay, then How to prepare in the laboratory, lab preparation of the carbon dioxide. So how it is done? When metal carbonate is reacted with dilute acid, it will give us carbon dioxide. For example, see, carbon and marble chips. Okay, that is calcium carbonate, we call it. Marble chips are called calcium carbonate. So marble chips, when the chemicals with this the chemicals required for this reaction is marble chips with reacted with dilute hydrochloric acid. That is, marble chips and dilute hydrochloric acid is uh, reacted to each other to form this this reaction. Okay, excuse me. Another things are required, that is a Wolf's bottle, a thistle funnel, a rubber stopper. Then rather two rubber stoppers are there, needed, because Wolf's bottle has two openings, two uh, mouths. Okay, then delivery tube is required, a gas jar is required. So what's the procedure? First, some marble chips are placed in the Wolf's bottle. Then through one mouth of the bottle, a thistle funnel is introduced with the help of a rubber stopper in such a way that the stem of the thistle funnel will dip in the acid which is kept in the bottle. Okay. Now, through the second mouth, the delivery tube is fitted, and the other end of the tube is inserted into a gas jar. Other end of the this delivery tube is fitted into the gas jar. Now, dilute hydrochloric acid is poured into the bottle through the thistle funnel so that the chips are completely immersed in the acid, and also the thistle funnel is also this end of the thistle funnel, it will be dipped in the this one. HCl, that is dilute hydrochloric acid. After this happens, then a vigorous chemical reaction will take place, which will liberate carbon dioxide, and that will be shown by effervescence. Brisk effervescence will be seen, and that will indicate that carbon dioxide is being liberated. Now, to collect it, first we need to release some of the bubbles. Let it escape. Some of the bubbles are allowed to escape, as because they might contain some air or acid as impurity. Okay, then the gas is allowed to pass through the delivery tube and collect in the gas jar by upward displacement of air, as carbon dioxide is heavier than water, heavier than air. Okay, there's another reason why there is this upward displacement, why it is collected over air. Okay, so I'll stop here. First, I will ask you three questions in this. There's a homework for you, that is to find out why calcium carbonate, that is marble chips, are used in this reaction. Why dilute hydrochloric acid is used, not dilute sulfuric acid or any other acid is used. Especially dilute sulfuric acid is not used in this reaction. Why it is so? Why marble chips are there used, and why this gas is not collected over water. Okay, so please find out these three questions. I'll come back in my next video. When I'll do it, I'll tell you the answer about it. I'll discuss that. But I want that you first find out these questions. Okay, these answers. Okay, so see, this is the preparation, how it is done. Okay, this is the Wolf's bottle. This is the marble chips. Then this dilute sulfuric acid is added to it. Okay, and this made it okay, and this is the delivery tube which is collected in the carbon dioxide is collected over the this gas jar. Okay, so this will be the diagrammatic representation of the representation of this lab preparation of this carbon dioxide gas. Okay, so please go through this. If you have any doubt, please do let me know. Write in the comment box. Share with your friends and relatives and colleagues. Okay, so that they can also be benefited from these videos. And also do subscribe to get the notification of my next video. Thank you for watching, and have a good day.